warp speed or Star Trek warp drive may be possible with tremendous amounts of energy. This is by Lu Chiao via Epoch Times. This is on Bended Reality. People have long dreamed of traveling to other stars and planets, wandering in the universe with a starship. But such things only exist in science fiction up to now, because even the closest star to the Sun, Proxima Centauri, is more than 4 light years away. This means that even if you could travel at the speed of light, it would take you more than 4 years to reach the closest star. To allow the Star Trek characters to quickly reach any part of the universe, Star Trek introduced the concept of warp speed, which lets the starships travel faster than light. But according to Albert Einstein's theory of general relativity, it's impossible to go faster than light. Then it's never possible to use warp drive? Scientists seem to have found a viable solution, at least theoretically. In a new study, physicist Eric Lenz from Göttingen University in Germany proposed a model for faster-than-light travel, thanks to what he calls a new class of hyper-fast solutions. They're kind of a wave that maintain its shape and energy and can move at a constant faster-than-light velocity. According to Lenz's model, these hyperfast soliton solutions can exist within the framework of general relativity, and with a sufficient energy supply, these solitons can be configured as warp bubbles with faster-than-light speeds. Please support my Patreon channel since YouTube has again demonetized my YouTube channel. My Patreon channel will have 5 different videos from my YouTube channel every day. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Thus theoretically enabling an object to travel through space-time without suffering from extreme tidal forces. The only problem with this solution is that it takes more energy than we have available right now. He said, the energy required for this drive traveling at light speed encompasses a spacecraft of 100 meters in radius, is on the order of hundreds of times of the mass of the planet Jupiter. This is what Lenz explains in his statement. He says the energy savings would need to be drastic, of approximately 30 orders of magnitude, to be in range of modern nuclear fission reactors. Now, although the method is not possible right now due to the energy supply issue, it could be more practical than previous thoughts on faster-than-light travel, which rely on exotic physics. For example, artificial wormholes and Alcubierre drive involve an exotic physical phenomenon called negative mass. This refers to a type of exotic matter that would have less than 0 mass. For example, -1 pound. This type of matter would exhibit weird behavior under gravity and may allow faster-than-light travel. However, such exotic phenomena in principle only exist on quantum scales. There is no obvious way that we can make macroscopic objects have negative mass. The new model, on the other hand, uses the characteristics of space-time to facilitate faster-than-light travel, and it only requires ordinary positive energy. Lenz said in his statement, this work has moved the problem of faster-than-light travel one step away from theoretical research in fundamental physics and closer to engineering, and the next step is to figure out how to bring down the astronomical amount of energy needed to within the range of today's technology. Such a large modern nuclear fission power plant could do that. And we can talk about building the first prototypes, he said. Fortunately, he says, several energy-saving mechanisms have been proposed in earlier research that can potentially lower the energy requirement by nearly 60 orders of magnitude. Lenz is currently working on determining whether these methods can be modified or whether new mechanisms are needed to bring down the amount of energy required. The new study is described in a paper in Classical and Quantum Gravity. This is on Epoch Times by Lu Chiao, and it's on Bended Reality. Thank you for your support.